Hi, hello everyone. So, I welcome you all to this next lecture. So, in this lecture, we are going to see about overhanging beam. As I have already explained you, right, what is overhanging beam? Overhanging beam is nothing but the beam which is extended beyond the support. Okay, I will repeat it. The beam which is extended beyond the support. For example, if we consider a simply supported beam, if this is a simply supported beam, okay, this beam, the two ends of the beam is supported on a support. It is supported. The ends of the beam is supported. But if the end of the beam is extended beyond the support, if it is extended, for example, if it is extended beyond the support and there is no support, it is free, means that support, that end of the beam is free and it is beyond, extended beyond the support. So that type of beam is called as overhanging beam. So we can tell this as overhanging beam, or we can tell like this: two supports, the end of two ends of the beams are extended beyond the support. So these are called as overhang beam. I have already explained to you in the introduction part of simply some shear force diagram. So if you could check, you can please check that. So in this lecture, I am going to teach you how to draw a shear force diagram and bending moment diagram for overhanging beam. Okay. So they have given the diagram, the question. As you can see, I will explain you the diagram first. So there are two supports A and B at a distance of 12.5 meter. That is 5 plus 2.5 plus 5 is 12.5 meter. And the beam is extended beyond the support B to a point of E. So the distance between that support to the beam which is extended will be 2.5 meter. Okay, this is the question. And we will see what are the loads that is acting on the beam. So let a UDL of 1000 Newton per meter is acting from a point A to C at a distance of 5 meter. And a UDL of 1600 Newton per meter is acting at a point of B to E at a distance of 2.5 meter. And a point, 2 points are acting from the support A at a distance of 5 meter. So that will be point C. At the point C, that is 8000 Newton. And another point load is acting in the center of the beam. That is 4000 Newton. See here, unit is all given in Newton. So that means your shear force unit is how what? That will be in Newton only. And your bending moment unit will be in Newton meter. Okay, it will be in that only, Newton meter. Because all your span is given in meter and all your load is given in Newton. So your bending moment will be load into distance, that is Newton meter, and your shear force will be simply load. So that unit will be Newton. So now let's move on to the problem. So what is your first step before calculating shear force and bending moment? What will be your first step? You have to calculate the reactions. Why you have to calculate the reactions? Because if there is a support, you have to calculate that support reaction, because that support will also make a force upwards. As you can see, the support also make a force upwards towards the beam. Okay, so we have to calculate reaction for these two supports also. First we have to calculate. So the force that we are going to calculate at the supports will be called as reactions. Okay, so we have to find reactions on what are the two supports in the beam? Supports at A and supports at B. Okay, so your first step is, so find reactions. So what is, how you find reaction? Reaction A plus RA plus RB is equal to total load. So now find the total load. What is total load? Total load is equal to, what are the loads are there? There is a UDL. One load UDL is there. UDL is at the span of 5 meter. So then write 1000 into 5 plus one point load is there. This point load doesn't have any span because it is acting in a particular point. So simply you take the point load 8000 plus another point load 4000 plus again UA at a distance of 2.5 meter. So 1600 into 2.5. So your total load will be equal to 21,000. The total load is equal to 21,000. What is the unit of total load? It will be in Newton. Okay. So 21,000 Newton. So now we have found the total load. Next we have to find any one of the reactions. So after that we will substitute any one of the reaction and we will find the another reaction. Okay. First we have to determine whether we are going to go from left to right of the section or right to left of the section. See, this is my right of the section, this is left of the section. Whether I am going from left to right or right to left. Okay. So it will be very easy to understand if you go from right to left. Okay, right to left. So you have to go from right to left. RB into the distance in the right of the side. Okay, if you want to go from right of the section means you have to take moment at A. If you have to go from left of the section means you have to take moment at B. Please note the concept. So I am taking moment at A because I am going to go from right of the section. So taking moment at A. So that is equal to, so from here to here I am going moment. So you know what is the sign convention of moment? If it is in this direction, that will be positive. If it is in this direction, it will be negative. So I am going like this from here to here. This is what direction? It is upward direction. So this will be RB. So RB into the distance. What is the distance? 5 plus 2.5 into 5, that is 12.5 meter. So right, RB into 12.5. Then this load is coming in this direction. This direction is what? Downward direction. Downward direction means it is negative. So minus 4000 into 5 plus 2.5 is 7.5. So minus 4000 into 7.5. Then minus this load 8000 into 5. 8000 into 5. Then this load is also in downward direction. Minus, since this is the UDL, you have to go for minimum calculation. How you will take UDL? You will take for load into distance by 2. If it is shear force means it will be what? Simply load into distance. So now it is UDL. That means what? Load into distance by 2. Minus 1000. What's the distance? 5 into distance by, that is 5 by 2 is equal to 0. This is how you will write the equation. So if you solve that equation, you will get an answer of RB is equal to 11,000 Newton. If you solve all these things, you will get a minus 1 answer. If you get that side, it will become plus. And if you take this multiplication to the left side, it will become plus. Division. So if you divide that value with this 12.5, you will get the answer. So that answer will be 11,000 Newton. RB is equal to 11,000 Newton. So now substitute this RB in this equation. Okay. So what is total load? That is 21,000. Okay. So RA plus 11,000 is equal to 21,000. So what is RA? RA is equal to, if you can take this 11,000 to the upside, it will become minus. So 21,000 minus 11,000 is equal to 10,000 Newton. So RA is equal to then RA is equal to 10,000 Newton and RB is equal to 11,000 Newton. You understand the concept of shear force and bending moment diagram? Yes. To calculate shear force at each and every point. How many points are there? You have A1, 2, 3, 4, 5. So you have to calculate shear force for each and every point. So first I am going to calculate shear force at A. If I am going to take shear force at A means, see, while calculating shear force also, you must only want to determine whether I am going to calculate from the left of the section, or right of the section. Any two you can do, but the answer will be same one. Okay, you can go for any two. So I am planning to go from left of the section. So if I am going from left of the section means, first draw the sign convention for shear force calculation. That is what? If the left of the section, if there is a upward direction means positive, and also in the right of the section if there is downward direction it is positive. In the left of the section if there is a downward direction it is negative, and also if in the rest of the section, right of the section if there is upward direction it is negative. This is your sign convention. So I am going from left of the section. So first I am going to concentrate on only point A, shear force at A. See only point A, forget all these sections, only see point A. In point A, what is that? There is a upward reaction force is there. So in left of the section, if there is a upward force means that is what? Positive. What is that upward reaction? That is 10,000 Newton. So directly you can write 10,000, right? That's the FA is equal to 10,000 Newton. Understand? Next one is I am going to take shear force at, see, because I told in each and every point we have to calculate shear force. What is the shear force that is acting? So at point C I am going to take shear force. I have already planned I am going to take from left of the section. So from left of the section, see at point C means from left of the section forget all these sections. So see, consider only these C and A. From left of the C, from this point C, what is left? See, these whole sections are considered as left section of this point C. So I am going to take the left of the section. So what are the forces that are there in the left of the section? At point C there is a vertical downward load and UDL is there and the upward reaction forces there. Yes, am I right? So how can we write that? So there is a upward force at the left of the section that is positive. So 10,000. Okay, and there is a downward force on the left of the section. If there is a downward force on the left of the section means what? It is negative. So minus UDL means what? It is distributed to a particular span. For shear force calculation is simply load into distance only. So minus 1000 into distance 5 meter. And again in the left of the section there is a downward direction. Left of the section if there is a downward means it is negative. So 10,000 minus 1000 into 5 minus 8,000. Okay, that is the thing here. That is to be minus 3,000 Newton. Understand? And after that, you have to calculate. So now I have found my left of the section. Now I am checking simply if I am taking right of the section. Okay, if I am going for right of the section, how it will be. So from the right means you have to consider only this right sign conventions. Only this right sign conventions only you have to consider. So from right of the section, from here to here, forget this remaining left of the section. So from right C, from point C, I am going to concentrate this whole right section. Okay. So what are the right section? There is a 1600 UD is there at the span of 2.5 meter, and there is a point load is there at the D, and there is a vertical load at point C, 8000 Newton. So these three loads are there in the right of the section. So I am going to consider only this right section because I am going to consider the right section only. So I am going to consider only this right section sign convention things. Okay. So this is at the downward direction. So this downward direction at the right of the section means it is positive. Okay, so plus 1600 into 2.5, load into distance 2.5. Then this load. Then here one reaction is there, right? See at the point right of section there is an upward reaction force is there. That is what 11,000 Newton is there. In the right of the section, if there is upward, see the right of the section there is an upward force. If there is upward force means that will be what considered as negative. So that is minus 11,000. Minus 11,000. Then at the right of the section there is a vertical downward direction. Right of the section there is a vertical downward direction. That is what 4,000 Newton plus 4,000 and again a vertical right section plus 8,000. If you calculate, the answer is 5,000 Newton. So shear force I am going to calculate at the left. The value is minus 3,000. And again I am calculating on the right of the section. It is plus 5,000. So in that simple area, if I consider from left, there is a different value. If I consider from right, there is a different value. Okay. So I am going to take these two values. If you do for force at D, that is center point, center of the beam. If you do shear force calculation for point B, both the values should be same only. It would come minus something. Okay. So that's the thing. So then next. So you know how to calculate force at C or L, that is the left of the section and right of the section, right? Then force at D. I am coming from left of the section. I am coming from left of the section. So what is this? This is left of the section plus 10,000. See plus 10,000. See you already know. See you already know this thing, right? You already know this thing. Only this additional D point is there. See you already know. See how you will calculate D at the left of section. You consider this upward load, this UL, this downward direction, and this direction. Till point C, you have already found the value. Till point C, till this 8,000, you have already found what is that value, that is minus 3,000. So you can directly write this minus 3,000 in this FD, right? You can directly write. Then you can add this vertical load. What is the vertical downward direction to the left of the section? Vertical downward direction to the left of the section is minus 4,000. So minus 4,000. You understand the concept? See, this 3,000 is already you have calculated in F of C. Till this year you have already calculated. Only this vertical load to be additionally added. Okay. So you are adding the only particular. So this is the downward direction from left side I am considering. So left section is two only left section. This is left section is L, right, L, left of section, only L content. The left of section there is a downward direction, that is minus 4,000. So your answer will be minus 7,000 Newton. Okay, next one, force at B. Again I am going to calculate from the left of the section. Okay, so at B, if you see from left of the section, what are the things on there? This total beam is there at the point B. So what are the loads out there? At point B there is an upward direction. At B there is a downward. There is downward point load, and there is a UL, and upward A is load is there. Yes. So still here we have found the shear force. Still here we have found it. So what is force at D? That is minus 7,000. Okay. So you can directly write minus 7,000. Only one thing actually you will add is this upward direction. In the left of the section, if there is upward means what? It is plus. So minus 11,000 plus 11,000 is equal to 4,000 Newton. Understand? Next force at E. Okay, force at E. So I am again already I have taken the left of the section. I am again calculating the left of the section. So at the E, what are the left section? There is UL, P, B, C, UL, and A is there. Okay. So till B you have already found the value. That is what? 4,000. Only remaining part is what? This UL. So I will get the 4,000. See, from the left of the section, this is acting in a downward direction. Downward direction means that is what? Negative. So minus 1,600 into load into distance, because it is UL. Minus 1,600 into 2.5. So your value will be 0. You understand? So this is how you will calculate your shear force calculation. Next one, bending moment calculation. Okay. So moment at A is equal to 0, moment at E is equal to 0. Why? Directly I have wrote moment at A is equal to 0, moment at E is equal to 0. So according to the rules that I have given in your shear force and bending moment introduction part, I have given you some part of rules. Okay. So in the rules, if there is any support while calculating bending moment, in the support it is 0. Okay, all the supports while calculating bending moment will be 0. Okay, but here I am taking only moment at A is 0, but B is not 0 because after B some extension of beam is there. If this B is simply supported, if there is no beam extension beam, it is the beam ends will support. That means moment at A is equal to 0, moment at B is also 0. But at point B there is extension of a beam till point E. So this will be not 0, we have to calculate moment at B because here this beam will make a moment at point B. So at this support there is no extension. Okay, so this moment at A will be 0, and there is another rules. Rule number 8. There is another rule. The bending moment for overhanging beam at the free end will be 0. So what is the free end here in the overhanging? This is the free end. This is free end. There is no fixed end. There is no support there. This is free. So the free end will be 0. So directly I wrote moment at A is equal to 0, moment at E is equal to 0. Understand? Next, I have to calculate C, D and B. Yes? So first I am going to calculate moment at C. Okay. So I am going to come from the left of the section. So while you are going to calculate moment, bending moment calculation, draw the sign convention, take the sign convention of bending moment. If it is upward means, it's upward means it is positive, it is downward means it is negative. See, I am going to take moment at C from the left of the section. So this is moment at this point I am going to take. At this point means this load, this vertical load at point C will not make moment bending. That's bending. See, this is the beam. This point, see, this is the point C. This is point C. I am considering this end as point C. Okay. So how will this beam will bend? It will bend like this only. Okay. So changes are this there in this part only. But at that point, the point is fixed. There is no change, right? It is in the normal dark portion. So the point vertical load, see the vertical load in this point C will never make any bending moment at point C. But the load after this point C. So here after point C, what was the load? This is udel. So this udel only will make this beam to bend. And also there is another reaction. RA is there. That reaction will make the beam. It is upward action. It will make the beam to go upward. So this reaction at A and this udel will make this beam to bend in different direction. Okay. So if you are going to consider point C bending moment, if there is vertical moments, you should not consider that point load because that point load will never make a bending at the entire left of C. From left to only I forget all this right section. From left section, what is that? C, udel, this is there. Understand? So using the sign convention, calculate the value. First is RA is there, 10,000 Newton. So while calculating bending moment, if it is a point load means you will consider it in load into distance. If it is udel means load into distance by 2. So here is a vertical load. So force into distance till point C. So it is in this direction. From here to here it is in this direction. This is what? In upward direction. Upward direction it is positive. So 10,000 into what is distance till C? It is 5 meter. So 10,000 into 5. Okay. Then this load. this load is in downward direction. Downward means it will come like this. So it is downward. It is minus. So minus 1000 into it is UDL. So distance into distance by 2. So 1000 into distance into 5 into 5 by 2. Your answer is 37,500. Since your unit is Newton, so Newton meter. Understand? Next one, moment at D. I am going to consider moment at D on the left of section. Forget all this right section. Only the moment at D. What are the roads there? There is a bigger point over there. There is a UD is there. And the upward reaction force is there. Now you can consider this point node, because this point node will also make this beam to this entire section to bend. But the point load at the D will not make, because this point load D only we are going to consider as bending moment. So at the point load D, the vertical load will not be considered. It will not make any bending in the entire section. You understand the concept? So now do the calculation again. So from here to here you are going to calculate what is distance 5 plus 2.5 is 7.5 meter. So it is in a upward direction till point D. So loading the distance for vertical load 10,000 into the whole distance 7.5. Okay, minus, because it is in downward direction this UDL, minus 1000 into distance by 2. After that a small portion of distance is there. While considering UDL, if there is a small portion of distance that does not come under UDL, you have to take that distance also. See, I am taking the distance. See, 1000 into distance is 5 meter into 5 by loading the distance by 2, 5 by 2 plus this small load up to D. That is what? Plus 2.5. You have to calculate like this only. You understand? So next, minus the point load is there. So this point load also will act like this in a downward direction. So that will be 8,000 Newton into what is the distance? 2.5 meter. 8,000 into 2.5 meter. So if you solve this entire thing, you will get answer MT is equal to 30,000 Newton meter. Understand? Next one is moment at B. Moment at B. See, I can take this entire from the left of the section also. See, from left of the section is from here to all these things. How you calculate? 10,000 into the whole distance, that is what? 12.5 meter minus 1000 into 5 by 2 plus this entire distance will be. That is what? 1000 5 by 5 into 5 by 2 plus this is 7.5 minus 8,000 into 7.5 minus 4 into 5. You can go like that. If you do like that means your answer will be same only, minus 5,000. Same only, you can check it, minus 5,000 will come. But instead of going for all the section, here simply I have taken from this right of the section. This simply is nothing to right of the section. So only this section I am considering. This is right section, from right I am considering. So from right, again bending moment is in downward direction. Okay, from right of the section means at this point I am considering. So in this point, this upward direction will not change, make any bending in this entire section. So what are the remaining load? That is only 1600 UDL is there. So 1600 into 2.5 into 2.5 by 2 is your bending moment calculation. But it is in a downward direction, that will be minus 1600 into 2.5 into 2.5 by 2. So that's your answer is minus 5000 Newton meter. So it's very simple. So this is how you will calculate your bending moment and shear force calculation. So now it's time to draw shear force diagram and bending moment diagram. Okay. So extend every point. Yes. So first I am going to draw baseline shear force diagram. Next, so what is force at A? Your force at A is nothing but 1000 Newton, as you already calculated. It is 10,000 Newton. So first mark the point. So point marking 10,000 Newton somewhere here. Okay, 10,000 Newton. Next one, your force at C at the left section is minus 3,000, at the right section is plus 5,000. So 5,000 will be somewhere below 10,000. So 5,000 minus 3,000 means below the baseline. Minus 3,000. Minus 3,000. Next one, your force at D is nothing but minus 7,000. Minus 7,000 is below. Force at D is minus, some marking somewhere here, minus 7,000. Next one, your force at D is nothing but 4,000 plus 4,000 above baseline. So it will be somewhere here. And your force at E is 0. 0 means this neutral is baseline 0. Okay. Now draw the shear force diagram. So since it is a UDL, if it is in a UDL means your shear force diagram will be inclined line. So draw a inclined line. Yes. Have you finished? Next one. Since here there is no load. There is no load. So after B, your D is below baseline here. Okay. So how you will draw? So here one vertical load is there. So it will be, it is minus. Minus means below baseline. So I am drawing a vertical line till here. Okay. Now in this area there is no load. No load means it is horizontal line. I am again drawing a horizontal line. Okay. And here again it should come up again like this. Okay. So here one vertical load is there. So I am going like this. And here there is no load. I am joining this load to here. And here there is a vertical load. Joining here like this. And here UDL. UDL means inclined line. So I draw inclined line and join this. Okay. So this is your shear force diagram. See why I am highlighting this? It will give a better appearance to your shear force diagram calculation. So you better highlight your shear force diagram. So you can show in this area the shear force acting. Shear force diagram will be like this. So it will be effective also. Okay, now we understand how to draw shear force diagram. So next we have to draw the bending moment diagram. So draw baseline. So bending moment diagram. So what is your moment at A? Moment at E is 0. So our moment at A is 0 and moment at E is also 0. What is moment at C? Moment at C is 37,500. So I am marking somewhere here 37,500. Marking 37,500. Next one, moment at D is 30,000 below that. So I am marking somewhere here. So 30,000. Next one, moment at B is minus 5,000 is below baseline. Moment of B is minus 5,000. So marking somewhere here. Okay. After marking, draw the bending moment diagram. See, from E to B there is a UDL. UDL means in the minimum calculation that will be a parabola, right? So from E to B I am going to draw a parabola. So draw a parabola. Draw a parabola. Okay. Next, from B to C there is no UDL, only point one. That means what? It's an inclined line. So draw an inclined line. Draw an inclined line. Okay. Next, from A to C there is a UDL. That means you have to draw again a parabola. Draw a parabola. Okay. So this is how you will draw a bending moment diagram. So I think that's it. So this is your shear force diagram and bending moment diagram for the given overhanging beam section. Okay. So students, this is the end of your unit number 3. So in the next video lecture, I am going to teach you unit number 4. So unit number 4 consists of moment of inertia. So in the moment of inertia, we are going to see the basic concepts and the problems related to moment of inertia. So what are the things that comes under the syllabus? I am going to teach. I am going to teach you all these kinds of things. Okay. So don't miss to watch your unit number 3. So from your unit number 3, I have already told you 18 marks is going to come in your Universal 3 examinations. Okay, students. So this is all about your unit number 3. I want everyone to practice more questions, because single questions will not make you give you a clear concept, a better idea about question. So this is the basic concept I have given you. Using this concept, every question will solve every question using this concept only. So reactions, how you will calculate reactions, how you will calculate load, bending moment, shear force, diagram, everything. Basic. This is the concept. But according to your question, it may vary. The diagram may vary. Okay. So I want everyone to take your different questions and solve it up. Okay. Concept is simple. You can get the answer. Very simple questions. Okay. So practice makes a man better. Okay. Perfect. So I want everyone to be perfect in this drawing, shear force diagram and bending moment diagram. Okay. Thank you.